Hello and welcome back to Universe Sandbox 2, and we're on a roll with these videos. Now we just gotta get that roll and smother it with some garlic to make it nice and yummy. And to do that, you know what we're gonna do? I have no clue. You know, this game has absolutely infinite bounds of possibilities and knowledge. But for some reason you guys wanted me to dump water on the sun. So I guess we're doing it, guys. We're doing it. We're doing terraforming the sun number 3 because the other two weren't enough, and Silly said that I have to do a third one, and because he's the vice president of Vooperia, so who am I to say no? So we're gonna dump water on the sun. Now the question is, how much water does one need to dump onto the literal sun to terraform it? That's a good question. We're gonna figure it out. Let's get the water. Let's turn up the rate. Let's turn up the amount as well, because I have a feeling that, you know, if we like 1 Jupiter, maybe like 1 Earth per particle. Hello? Oh, there we go. We can do 1 Earth per particle, sprinkle some of that water, and it's gonna be beautiful. Let's see what happens. We are now sprinkling water onto the sun. Is it actually? Oh, it is. We are actually sprinkling water onto the sun. The water does not actually appear to be going into the sun. It is going behind the sun. What the actual heck? Okay, let's what? Okay, we're gonna need a more creative way to solve this problem. I propose that we just get the sun. Remove it from the solar system, it'll get much simpler. Okay. We have removed the sun. Good job, team. We have saved the world from skin cancer because there's no longer a sun. Here we go. Okay, here we go. 1 Earth per particle of water about to literally crash into the sun. What could possibly go wrong? By now it's definitely steam and probably even plasma, some of it. The sun does not seem to care. Now, to be fair, I didn't think that the sun would care. The sun is rather large, and all of that added 0.01 suns, even with each of those particles being 1 Earth. So we're gonna have to add a lot more water. So, yeet, a lot. See all the, I don't know if you can see it because they're so tiny and bright. YouTube's compression may kill it, but if you can see each one of those dots, which is making up these swirlies, is 1 Earth. 1 Earth of water. So we're talking a lot of water now. Okay. So it is inflating, but it's not enough. We're gonna have to switch to 20 Earths per particle. We need to dump a lot of water on the sun. Here we go. How much water is it going to take before the sun decides to do something? Okay, the sun does not seem to care. We're gonna force it to go through a supernova. This is the only way we can do it. Here we go. We're just going to explode the sun. It's gonna be fine. Just boom. Okay. There was nothing left. There was nothing left over. That's not good. We wanted to have like a neutron star or something left. That is not going to work for terraforming the sun. That is unfortunate. It looks like we're going to have to use... So, I don't want to cheat. I don't want to just, like, remove mass from the sun, because that's lame. Just removing it, that's so lame. Instead, we want to try to rip the mass off of the sun. So what we're going to do is we're going to terraform the sun using the only thing overpowered enough to terraform the sun, which is a black hole. So, let's grab a black hole with the mass of the solar system, which is going to be just about the mass of the sun, and let's get the sun really close to it and orbiting it. And what that'll do is it will slowly suck away the mass of the sun. Come on. Oh, look at that. That worked really well. Okay, so the black hole, hopefully the sun doesn't hit it. Oh, look at all the mass it's ripping away. This is exactly what we wanted to happen. So it's going to continue ripping the mass out of the sun. And this is going to get us closer to terraforming it, because we need the sun's mass to go down to like a reasonable amount. Okay. So the black hole is just eating the sun. Fantastic. Here we go. 418 Jupiters. Oh, 411. I mean, we have gotten rid of a lot of mass, but it's still doing nuclear fusion. So we gotta get more mass off of the sun, which means I think we're going to have to actually increase the mass of this black hole so that it gets a little bit closer. Oh, wait, that got really close. Okay, 352 Jupiters. Like, this is still ridiculously large because it's a star, but oh, 327. Okay, so we're gonna delete this, and we're going to kill the velocity, 0 velocity on the sun. This is good work. We have actually gotten the sun much, much closer to our goal. Now all we have to do is orbit the sun around another black hole and hope that it rips it apart more. This is all about trying to remove the sun's mass without just removing the sun's mass, because it would be very cheaty if we just decrease the sun's mass. What's the fun in that? So auto orbit. Uh-oh, we've got an error. Does it not want to orbit the black hole? Oh, no, it certainly does want to orbit the black hole. Oh, look at that. The Roche limit kicking in, heating up the sun from being ripped apart gravitationally, and the fragmentation's taking place. They're doing a little dance. The sun is now at 266 Jupiters. We're actually getting very close to our goal. Okay, the sun is slowly losing mass still, but it's also kind of gaining it back. It's in a very large battle right now. With everything else that's going on. Like, the black hole is really having a lot of fun, but it's not really effective, you know? The sun's just getting all of its mass back. Okay, sun, you're at 239 Jupiters. I wonder if we could... You're still a star, but I wonder if a collision with an object large enough would cause you to lose mass. Or it would cause you to supernova. Like, no, you are around the size of Jupiter, my friend. Okay, wait, so if we 0 velocity this... Wow, the sun is really small right now. Okay, so if we oh boy, lots of errors. Okay, if we very carefully launch Jupiter so that it'll graze the sun, like this, we can try to knock some of the... Oh, look at that! Oh, it's doing so much damage. Okay, if it grazes it enough that it knocks out more material than it gains from the collision, although there's nothing really to stop it from regaining. I mean, some of the particles will go out faster than the sun's able to reclaim them. I need to get a better impact than that. Okay, let's try this again, but like further in this direction. We really want it to just graze. Ooh, yikes. Okay, so it looks like we're definitely able to rip some of the material off of the sun. The problem is it gets it back so quickly. Okay, so that didn't work. That was too far. How to steal material from the sun. Make it the speed of light. That is a terribly awesome idea, so let's do it. This is going to go horribly wrong. So it will graze it at the speed of light because the sun won't have time to pull it in. But there are other issues. Like, it may just cause the sun to explode. But you know what? We're willing to take that chance, aren't we? Of course we're willing to risk destroying literally all of our work. This is my channel. This isn't some lightweights channel. Minimal editing and seeing all of my mistakes is the way to go. Here we go. Even at super slow motion, we're currently going 170 milliseconds per second. Like, this is super slow motion. Oh, look at that. Jupiter instantly vaporizing itself from the heat. The shockwave went over the entire sun. The sun lost like a quarter of its entire mass. Jupiter, Look at the temperature! Look at the temperature! Okay, what's that? 648 million degrees Celsius. If you want to get that in Kelvin, add 273.15 degrees Celsius to get it just a little bit more impressive of a number. Wow! Look at that heat! That's hotter than the sun it just hit. That's hotter than the sun it just hit. Jupiter became like hotter than like the creation of the universe. Probably not actually that hot, but it looks like we found a new strategy. Accelerate things to ridiculous speeds and you will see ridiculous success. I think that's got to be an Einstein quote, right? Right? Now explode the Jupiter. That doesn't seem like a good idea. Oh, we do it again. We graze the sun. The sun is now 166 Jupiters. And Jupiter, where's the temperature of this baby? Oh, this one's 812 million degrees. Wow. Okay, as you request, I will explode it. Although this is going to make an absolute mess. I don't even know what just happened. Okay, it's got to be going too slow for me to see, so let's speed up time a little bit. Wow. But this is going so fast. Look how fast we're going away from the sun because we're going at light speed. The explosion is going to take longer than like an entire... Oh my god. No, we gotta go back. We gotta go back. We're gonna lose the sun. Quickly, get back to the sun. Okay, whew. We made it away from the exploding light speed Jupiter, which is now dead. Okay, so the sun is not having a good day. Not at all. The sun is just being ripped apart. The sun now only has the mass of 166 Jupiters. It cannot be close to an amount where it can, it's got to be close to not being able to do nuclear fusion anymore. Like, we are getting to that point where the sun will no longer be able to keep itself stable. Hopefully, instead of going into a supernova, because we're removing so much material, it will just go out and turn into a very, very gaseous planet. And then what we'll do is we'll burn off the atmosphere using lasers. So let's go ahead and once again set this to 1 light speed. Okay, here we go. Motion, speed, 1 light speed. Here we go again. Oh shoot, I forgot that I turned the time back up. Did that actually hit? Oh, I accidentally deleted the sun. Good thing they added undo. They did that a while ago, but still good thing they added it. Okay. We're so close. We're so close. We just have to get 1 more good shot, and I think then we'll be able to just melt off the atmosphere of the sun after it turns into a planet. This all sounds very unscientific, but this is how we're gonna do it, so deal with it. Why are we headed in a direction that is not the correct direction? Velocity. Okay, let's just point you this way, my friend. This way. Here we go. Here we go. That tool is so useful. Okay, ready? The sun is about to get hit really, really... Oh, that may be too much of a head-on collision. Oh, nice. Okay, sun now at 120 Jupiters. It's not enough. But look at what we can do. This is beautiful. Watch this. We're gonna come back around again. Jupiter is not done yet, darn it. They're gonna take everything they can get. They've still got a lot of speed. Because it wasn't a direct collision. Also, I mean, it would take a lot... Oh, the sun is actually getting a lot of velocity as well from these collisions. Okay, come on, sun. You've got to be close. 104 Jupiters. Come on. How are you still a star? This is embarrassing. Okay, let's see if we can stop it by turning down the temperature and praying that the nuclear fusion will stop. Let's freeze the sun. Oh, shoot, that worked. Guys. Oh, wait, never mind. That didn't work. It's still a star. Still a star. Just turned dark. Darn it. Okay. The question is, why aren't we removing mass anymore? I think we've gotten the point across. I mean, we've gotten it to 113. Let's just see how low we would have had to go. Okay. 110. I mean, it's got to be so close. 90? What is it? Like 80 Jupiters it needs to be a star? Yep, okay. So now we're at 77. So it wouldn't have taken that much further. Now, ready for how we're going to turn it into a solid planet rather than a... Oh, well, I guess we're going to have to cheat a little bit for this. So we're going to add silicate because there's no other way to really add silicate other than just plain adding it. But let's pretend it was there in the first place. And we'll add water later manually. So what we can do is very carefully with the laser, we can burn off the lighter elements, which are going to be the gases. So let's get our laser, turn up the power, and let's just make a nice strip here. We're going to increase the temperature. Okay, great. And now we're going to do some real damage. Sorry, we have to burn off your atmosphere, atmosphere, atmosphere. We've got to burn off your atmosphere. So the average surface temperature is at 500 degrees now. But we've got to get it hotter than that. We've got to get it much hotter than that. So we're going to increase the radius by 10 times. Oh, that got it to, a little bit over 1,000. Oh, it's like baking, except it's an entire planet. Oh, there we go. We can see the gases struggling. Oh, turned a little blue. We need to get it to the temperature where it's shedding off its outer layers, but not the inner silicate layers. I'm thinking that if we heat it up enough, it'll work now. I mean, I'm hoping, like... Oh, there we go. Okay, now it's working. Great. So we are now jetting the atmosphere, which is exactly what we wanted to do. The mass is going down as well, which is another thing that we had to do in the first place. Fantastic. Fantastic. Now, something we have to be very careful with is making sure that it doesn't lose everything. The hydrogen's gonna go first, but then everything else is gonna start to go as well. Okay, so we're gonna slow down, and once that hits 0% hydrogen, it's like a cookbook, except more death. Okay, here we go. We've hit 0. We've hit 0. Now we're getting rid of the silicate. So we've... Actually, no, we're draining water now. So we want to get water to 2.4%. It's actually really good. That's actually perfect. Okay, now we want to turn the heat down. Turn the oven off. Set it to 20 degrees Celsius. Okay. Nope, that did not work. Set it to 20 degrees Celsius. Oh, God. Oh, God, it's not letting us undo it. We've got a cool, could I, let's change the average surface temperature to 10. There we go. That worked. Let's get our water back. We were a little bit too slow to save it. Oh, there, it's gone again. Actually, now that there's water physics, let's do it the old-fashioned way. Let's not make it 20 Earths worth. Let's do, like... that amount? I don't know what that amount is. It's not a visible amount, so maybe that's not a good amount. Okay, let's do times 10 times 10. How much water? Okay, that's going up pretty quickly. Okay, guys. This is it. When will the water become visible? Okay, let's do another times 10. Oh, there we go. We've got visible water on the surface. We'll do times 10 one more time. There we go. Now we're putting puddles of water down. We're gonna quickly copy this object, or we will, can you copy it? Save this object, Sun 2, the electric boogaloo. We're just gonna make a new empty simulation so it isn't so laggy. And then we'll add the Sun 2 back. Here we go. Here's our good friend Sun 2. Sun 2, the long-awaited prequel, looking pretty good in theaters. Let's go over to the surface, set the average surface temperature back to 20 so that we've got liquid water. Very nice. And we can go ahead and start pouring that water down. And look at this. Look at this. Look at this. We're pouring that water down. And it's looking good. Wait, are those cities? Wait a second. It didn't make it into one of the alien planets, right? Because those are a thing. Okay, anyways, the ocean, no, it's just little bits of rock. The ocean is spreading over the surface, and if we give it a bit of time, it'll fill in all the cracks. Actually, no, there it is. There's the ocean. Wow, like one massive ocean. Very nice. That's actually really cool looking. Planet with one massive ocean. Wow, Sun, you look pretty cool. Okay, let's see if we can get you, like, livable now. Let's add an atmosphere with a surface pressure of 1 atmosphere. Ooh, looking good. Now the surface pressure is actually, there's not much. It would be very, actually, I'm not sure. So there's 133 Mars, but the gravity would crush you, obviously. This thing is 3 times the mass of Jupiter. So, like, we still did a pretty terrible job when it came to getting the mass correct. I mean, I can tweak that by myself. We can just do this. Oh, it's killing my beautiful oceans, though. Oh, that's sad. All I wanted was beautiful oceans, and this ruined it. Absolutely ruined it. Okay, so that's about correct. We can put more water on the surface, though. Here we go. Water! Water! Okay, fantastic. Let's give it a little bit of time. And a new ocean is forming. Give it a little bit of time. Really? Is it just going to form a circle there again? Huh, interesting. So I guess that, like, where we put the water, it decreases the elevation a little. We've once again, we've created a planet where one side of it is an ocean. Or is it just flowing? Let's give it some time and see if it's just flowing. Maybe we just made a water planet. Let's see where the water is now. No! We have literally made the sun half water and half not water. That's beautiful. That is absolutely beautiful. Look at that. What a neat planet. I'm a big fan of it. I'm a big fan of it. You want to go fishing? Live over there. You don't want to go fishing? Live over here. There's 2 kinds of people, fishers and not fishers, so it'll make everyone happy. Very nice. Now I do want to check one thing for the Vooperians. Before we end this video, I haven't actually checked what Spook Vooper is like in this update, and I feel like I should. So let's see. Spook Vooper, what do you look like? URS Spook Vooper. Ooh. Oh, is Spook Vooper broken in this one? Oh no, guys! Spook Vooper's not looking too good! No! Oh, they must not have made backward compatibility yet. Okay, they better add it, because I would be very... Is that just water? Is that the problem? No, the surface grids just make it borked. Okay, well, hopefully they fix that. I'll see you all next time. Take it easy, and I'm out for today. Ow, I just crushed my finger. Holy ow. Ow, 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 ow. F for my finger in comments. F. Ow.